April Fool's edition of the UARC meeting. And without any further ado, that's the end of the meeting. No, I'm just kidding. We got some announcements here, and there's something here for everybody. Jerry Wellman, you here? Okay, we'll get you in just about 1 minute, because Jerry's got to leave. Let's see. Field Day is coming in a couple of months. There's a sign-up sheet at the back. We need all kinds of helpers. People that know how to set up towers and antennas and power. People that know how to supervise people that set up towers, antenna, and power. People who can arrange to organize people to set up towers, radio, and power, and also some people to cook. We might need an operator or two in there, so this thing runs for about 24 hours. If you have an affinity to do any of those kind of things, or would just like to come up and make yourself known and pitch in a little bit of help, there's a sign-up sheet in the back. We have a very serious station, complete with Christmas tree lights and tents and everything else, so it's a lot of fun. Let's see, it said mention that there's food and fun on Field Day. Well, that's a given.
I was looking for two committees. We're going to have a May barbecue and do all this planning. I would like, if there's those who like to do a little outdoor cooking, would like to sign up on the Food and Fun Committee. The other committee would be the Operating and Equipment Committee. So we'd like, there are two sign-up sheets. And if you wanted to get in and have fun planning the thing, that's half as much fun as Field Day. Sign up for one of the committees, we'll call you, and we're going to put a barbecue together and sit down and plan it and have a little fun.
No kidding.
I mean, how can you lose? You get a meal before the dinner. Food and Fun Committee, let's see, if you didn't have that, then the operators would go home after about a couple of hours. If you had the Food and Fun no operators, then it would be Field Day. So it takes both of them to cause it to happen. Reminder for those that are interested in Packet or are on Packet or just want to know what Packet is or a number of things, we'll be having a meeting this coming Saturday. That'd be the 3rd of April. 4 o'clock, that's in the afternoon. For those of you that are DXers, that might be AM. 4 p.m. at the Calvin Smith Library. That's about a little below 9th East, like 850 East. Yeah, 815 East, 33rd South, south side of the street. Last month we had 30 people, roughly, there. Speaker this month will be Jerry Wellman, who you'll be hearing from in just a minute. Tell us how to use bulletin boards and what they're all for and how to get around bulletin boards. Let's see, test sessions. I'll announce that, and then we'll give some time to Jerry, and then he can get out of here. He's got to get to another program here. Test sessions are Saturday, April 10th. That's a week from this coming Saturday at the Blue Cross Blue Shield building up on 2455 Parley's Way. That's kind of what 21st South turns into. Contact there is Gordon, and he'll be up here in a second to make an announcement. Wednesday, April 21st on the UVCC campus in Orem. Contact there is Steve Whitehead here in Utah County. There's another one also in April that I learned about. Let me get my note out here. April 17th, the Bridgerland Amateur Radio Club, who is presenting our program tonight, is going to be holding a testing session at Utah State University, room 107, in the engineering building. Paul Hansen is the contact there. So it looks like in the month of April, there's really 3 tests. You ought to be able to pass, 3 times. That sounds like a pretty good opportunity. Yeah, I mean, novice to extra in 1 month. Okay, let's see. Let's get Jerry Wellman up here. Jerry's, this is an unpaid political announcement.
I got my arm twisted Saturday by Jerry Benyon to come up here for a minute and introduce myself. It wasn't planned, but I told him I would come up. I sent a letter out a couple of weeks ago. I'm running for the Utah section manager for the ARRL, and he wanted me just to come out and introduce myself. I don't really have a campaign speech because I'm not really sure what the section manager does yet, and that may question my sanity, and that probably speaks to why I'm here on April Fool's Day. So I don't know what to tell you except that that the ARL does represent the amateur radio community big time, and it's probably the one way you have a voice on frequency management and the changing spectrum. The frequency issue is going to be a big thing in the next 10 years or so because of the limited spectrum available and the demands being placed on it. And I'm primarily interested in emergency services and emergency preparedness, and it's exciting to see all the young kids here that have licenses and are actually the future of amateur radio. So all I can say is I'm open to questions and open to discussion. I'm listed in the phone book. You can find me in almost any directory. If you got Packet, you can find me there. By all means, call. I've been reading as much as I can about what the section manager does, and I've talked to several places back in California and also back in Michigan to find out what they do, because they have successful sections, and most of it's involving preparedness and training and working with clubs and getting materials out, and working with the news media, and working with public service groups other than radio groups. So that's really all I have to say. If anybody had any real pertinent questions, I don't know if I can take a few seconds. If somebody had anything burning, if not, I guess the president can speak. Yes, sir.
Jerry, how do we vote?
Okay, good question. The ballots were mailed out today from the ARRL headquarters. So if you're a member of the ARRL, you'll get a ballot, and all you need to do is just check your choice there. There'll be two of us, Rich Fisher, who is the incumbent, and myself, and pick who you decide and mail it back to the ARRL, and they'll tally them by May 20th, and I'll breathe easier on May 21st. Anything else? I do have another meeting, and thanks for your time.
ARRL report, anything to say there?
We got one real piece of good news this month, and that is that the FCC's responded to ARRL's petition for rulemaking on giving us access to some spectrum just below the old 220 band. Some of the newcomers may not know that we lost 2 out of the 5 megahertz on our 220 megahertz band a year or 2 ago to the land mobile service. ARRL had proposed that so that we could get some long-distance packet circuits set up, it would be nice if they could allow us to use some of the space just below 220, which in some parts of the country is lightly enough used that it can be used on a shared basis with the primary user. And the FCC has now issued a notice of proposed rulemaking that would propose to give us not the whole area, but at least the top megahertz of it, 219 to 220. And the fact that FCC seems to go along with the idea is quite encouraging. They're saying that ARRL's proposal of 50 watts power is reasonable. ARRL had proposed to limit it to novices 25 watts. So it's going to be a total freebie. So that should give technicians and novices a chance to get in on more of the action, provided that... go ahead, Jerry. I think that will probably be true. The rules will be out in May QST, but generally field day rules don't permit repeater operation. Packet's an exception. They do permit you to go through nodes there. Anyway, that might be something we can exploit with the UARC field day if we can figure out how to get somewhere. Update on the shuttle. As you probably know, the STS-55 was scrubbed about 3 seconds before launch. It looks like now 56 will launch before 55. 56 has a crew member that is 100% licensed amateurs, and they're expecting that to go up on the 6th. 55 should go up on the 27th, and 57, which also has some SARX activity, would be May 10th, according to the most recent schedule. So you might want to keep an ear out on 145.55, which is their downlink frequency. Do not, however, transmit on 145.55. You'll get unpopular in a hurry, and it won't do any good because they don't have a receiver on that frequency. So that's a downlink only, both for packet and voice. And late breaking news that a fellow named James L. Brantley, K6 KPS, had his license suspended for a year. because of intentional interference and broadcasting, both of which the Commission takes a rather dim view of. So maybe that will encourage people to operate within the rules. Any questions? Anything I could take back to the director on opinions on what the league ought to do, or questions? Oh, yeah, good point. A big issue for the last few years has been, well, about a year ago, the FCC issued a whole slug of citations because somebody issued a packet message that listed a 900 number and recommended that people support a particular political cause. And the FCC said, hey, that's business traffic, which was correct. But they fined not only the fellow that originated it, but all the packet stations they could find that relayed it, even though they're just kind of dumb machines that take what they hear and send it on to the next point along the chain. We didn't think that was really fair, but the FCC's response at the time was, well, we know that you're smart, so you can figure out some way to keep track of the packets that relay through your stations. And so that decision caused a number of major nodes to shut down and others to hold the traffic until the sysop could look at it before it went on to its next hop, which slows things down dramatically. Well, anyway, the FCC has now issued a notice of proposed rulemaking that would make only the originator and the first relay point responsible for content of traffic. And they said all the obvious things in the notice that we've been trying to tell them for the last couple of years, that the rules made sense back when messages were relayed manually, but now they kind of go quickly at the speed of light, and it's really not practical for an operator to watch everything that goes through his station. We're still not just entirely sure why the first relay station is responsible, but the subsequent ones aren't. But at least if that goes through, it'll be a lot better than the situation now. Anything else anyone would like to ask or suggest? Or okay, thank you.
Thank you, Gordon. For those that are standing, there's 1, 2, 3, 4, 5, 6, 7, there are about 8 more chairs down here in front, and that's where the TV sets are. For those of you in the back, you may want to turn around. There's a television set over there in that corner, so if you can't see these up front, you'll want to go over. Just a note about project night for April. There isn't one. Jerry and Verna are going to take the ultimate vacation, which is to go back to... There is one. There is one, okay. Anyway, they're still going to take their ultimate vacation and go back to Dayton. So, we'll all feel bad about them. The May project is scheduled to be solar panels, and as of the SwapNet Tuesday night, they should have been in town today. So there should be no problem getting them ready for the May project night. UARC purchased a number of those, not an awful large number, but certainly enough to probably handle the needs of the club. If you're interested in a 10-watt solar panel, framed up out the door for under $35 probably, that's fair to say. That's about a third the cost that you can buy one for. Contact Jerry or a member of the board. Anything else before we get the program started? Okay, then you can introduce Clint, who will introduce the program.
Thank you. I don't know, I built a little aluminum J-pole back there on the table. We're going to do that a week from Saturday, anyone who's interested. I don't want payment in advance, you just need to sign up. We're looking for a fairly small group. I was looking for an antenna that didn't look so ugly, stuck up on your housetop. That one works very nice. You can set it on a tabletop. You can attach it to a vent pipe coming out of your house, or there's 2 screws. You can just screw it to the eaves. It's real easy. Tunes right up. It turns out that 1/4-inch tubing was the biggest size that would absolutely cover the ham band and be flat. Anything bigger overlapped and you didn't need it, and anything smaller wouldn't really cover the whole ham band flat. So I thought it was a fairly fun little antenna. It should take about less than an hour to build. So anyone who's interested in joining us for our project night, we may have projected everyone out. That's okay too. We have one beam antenna and one twin lead or twin band J-pole that are still available. Those are the two that I brought for demonstrators left. So if anyone is interested in those, talk to me or Dirk back there. And we've really enjoyed doing Project Night. I've had a lot of fun with it. I appreciate everyone who's participated in it. We get to know each other and have a little fun, and so hopefully we can get the solar panel project going in May. That's going to be a big one. We'll probably do that several weeks. So I think we're going to have a good time with Project Night. I've enjoyed doing it, and I hope you have too. Let's see. We'll turn the time over to who? Clint? Clint, are you doing it? Or let's see. We're going to give Willie just a minute to talk about next month's meeting. Willie? Or is Clint going to do it? Willie and Clint, as you know, are our program chairmen. They just do a super job. We sure appreciate them.
Thank you, Jerry. Hi, my name is Willie Peak, N7VVL. Clint, KA7OEI, and myself have been setting up the programs for the meetings. And I'm just going to give a quick plug for next month's meeting. RDF, Radio Direction Finding. It's going to be quite a good show. We have some transparencies, some handouts. Mike, and I will give this an attempt, Malajovsky, WA7ARK. He's really an authority in the field. He also uses it as part of his Civil Air Patrol duties, so it should be a real interesting show. And now, Clint, for tonight's meeting.
All right. Some of the more recent amateur magazines, like I know for sure CQ and 73 Magazine, have featured balloon, amateur radio on balloon. And Gil Moore, who will be our speaker tonight, will be talking about that. The balloons that they do are a bit more involved than most of them, I guess, because I believe you're limited to just a few pounds normally without having to jump through a lot of hoops for the FAA, but they've been having much, much heavier payloads and things like amateur television transmitters with cameras, meteorological instruments, as well as packet and all remote, and putting up payloads that hopefully will stay up for days and days, or until they take them down again. And it's a really quite involved feat to do that, and I guess as Gil walks up here, we'll turn it over to him.
I appreciate the opportunity to come down tonight because I'm going to hook all you folks into this business, I hope. What I'm doing is inviting you tonight to participate. Well, you would be the principals in a high-altitude research balloon flight from the Salt Lake Fairgrounds, the State Fairgrounds, I'm sorry, over west of the river on the 18th of September. And I'll tease you a little bit with what's available and what you can do and what the fun things to do are, and then see if you would like to participate. If you don't want to, that's okay, but I think you'll find that this is an interesting thing to do. There are several things that have happened in the last few years that have sort of made possible some really exciting opportunities for ham radio enthusiasts to participate, amateur radio people to participate in meaningful measurements in the atmosphere. One of those things is the advent of the ubiquitous HT. You know, everybody's got a 2-meter rig these days. And that's the first thing that's happened. And there are so many new people in the business these days. You'll all have noticed, if you've done any taking exams lately, how long it takes to get your license back. That's because there's so darn many of us in the business these days. That's the second thing. I'm sorry, that's the first thing. The second thing is that there's been some revolution in the world of high-altitude ballooning. This is nylon. This is a new material that has replaced polyethylene and polypropylene and a lot of the other Kapton and Mylar and things like that that have been used in high-altitude research balloons in the past. And in the past, all of these materials have had pinhole problems, and they leak. So if you put up a balloon, in the first place, I'll get into some of the aspects of scientific ballooning in just a couple of minutes. But I want to say, first of all, that this new nylon material is a revolution in the business. That's the next thing. The third thing that's happened is that along has come the global positioning system, which allows you, with a simple little receiver about like yay, that draws practically nothing, a few hundred mils, to determine your position anywhere in the world, 24 hours a day, 365 days a year, to a positional accuracy of at least no worse than about 100 meters. That is the third thing that's happened that's really revolutionized ballooning. And the fourth thing is that everybody's interested in the atmosphere again. When I was a kid, a long time ago, and got very interested in the atmosphere and space and so forth, down at White Sands Missile Range in New Mexico, right after we captured German P-2 rockets at the end of World War II, I've been in this business all my life ever since that time. But people have been interested in and not interested in the atmosphere in kind of a cyclic fashion. Today, if you walk in any schoolroom in the country and you say, have you heard of the hole in the ozone layer, and have you heard of global warming, every kid everywhere has heard of that. Now that's only a recent phenomenon. That's only occurred in about the last 10 years. But everybody today is interested in what we're doing to the atmosphere. And what they have to understand, what we all have to understand, is there's a great deal of concern right now and darned little data. We really don't have enough information at the present time to know whether we are lousing things up or whether we're not, or whether Mount Pinatubo in 1 year has reversed 10 years of global warming. That's a fact. That actually is the case. The Earth now, global warming is not going to be a real big issue for a while, but contamination of the atmosphere with chemicals that in fact alter the dynamics of ozone in the atmosphere and thus the amount of UV that gets through to scorch us, that is something which we believe is actually a sincere problem. But we don't know how bad the problem is in the northern hemisphere. And although we do have a number of satellites, such as the UARS, the Upper Atmospheric Research Satellite, it makes measurements, but it has instruments that drift. And there's no way to get the instruments back down again and give them a post-flight calibration. And so we need, quote, ground truth or atmospheric truth measurements by balloons every once in a while in order to authenticate those measurements. Okay, that's another factor. We do have a lot of data coming from high-altitude aircraft and from these satellites, but we don't really know what's happening with ozone distribution in the northern hemisphere. Now, I'm not going to bore you with a lot of photochemistry, but it is really a complex question as to what happens when you put chlorofluorocarbons, for example, and other chemicals in the atmosphere that have very, very long lifetimes. In fact, they catalytically react with ozone and destroy ozone. They'll destroy an ozone molecule and cause it to go back to oxygen. They're not poisoning the atmosphere. They're just changing one of the O atoms on an O3 molecule. They're taking away that and putting it back to natural oxygen, which was what started out up there before the sunlight broke up the oxygen and created ozone in the first place. Every day, the sun creates ozone, and every night, it runs down. It destroys itself. But in addition now, we've got some chemicals that go up there and destroy the ozone molecule, and then they don't get consumed in the process. They are catalysts. They just keep replenishing themselves, and they keep killing off ozone. Well, so we really would like to know about these greenhouse gases. We'd also like to know about CO2 and water vapor and other things. All right. Now, the problem is that in the northern hemisphere, we have not been able to make in situ, in-place measurements of the atmosphere since 1957. We have not made consistent measurements around the globe in the northern hemisphere since 1957. The reason is, in that year, we, the United States, flew a whole bunch of balloons to snoop on what the Russians were doing with their missile sites and their atomic energy plants and that sort of thing, and they didn't appreciate it. And we didn't do a very good job, and we dropped an awful lot of these camera-carrying balloons in their country so they could hold them up on TV and say, look what these dirty Amerikanskis are doing to us. And Khrushchev said to Eisenhower, you do that anymore and I'm going to start a war. We flew hundreds of these things over a period of about 18 months. And finally he said, I'm going to start a war. So President Eisenhower said, no more. We will not fly any more circumnavigational balloons in the northern hemisphere. We flew balloons actually from Europe and Scandinavia, and they flew across the Soviet Union and were retrieved by C-119 flying boxcars. They parachuted the payloads down and scooped them up with C-119s off the Sea of Japan and up in the Aleutian chain and so forth. That's how the thing worked. Or in the summer season, they'd launch in that region over in the eastern side, and fly across and recover them in Europe. But an awful lot of them fell and were retrieved by the Soviets, and so we were guilty. Okay, so that we have, for that reason, we have not circumnavigated the globe in the northern hemisphere since. We have flown a lot of balloons in the southern hemisphere. Down in Antarctica, we've had balloons that, there are some up right now that go round and round and round and round for 30, 40, 50 days at a time. And you can go around the world a number of times when the winds aloft are about 150 knots. So, that's fine, but we haven't done it in the northern hemisphere. So, what we're trying to do up at Utah State is to fly a series of these balloons launched from points as far away as, say, Point Barrow, Alaska. We have agreements now with various universities that when we get this technology worked out, that we will fly on a volunteer basis. We're going to fly from Point Barrow and from from Anchorage and Juneau and from Seattle, Moscow, Idaho, Logan, Utah, places, well, University of Nevada, University of California, et cetera, all the way down to San Jose, Costa Rica. We have agreements with the University of Mexico, University of San Jose. And what we want to do is embed these balloons in the atmosphere, and we want them to stay up for 2 or 3 years. Now, this is the stuff that'll make that possible. This is totally impervious to helium. It does not leak. If I made a balloon out of this and hung it up in this room here, it'd probably stay about 30 years. But if I put it up in the atmosphere, at the top of the atmosphere, at around, say, any place up to 140,000 feet, the UV will slowly degrade the seams in this material, and ultimately it will fail, and we figure it'll take about 2 or 3 years to do that. Okay, so for the past 2 years, the Bridgerland Amateur Radio Club has been experimenting first with plain old rubber balloons like they fly here from the Salt Lake Airport every day for meteorological purposes, just to measure winds aloft, pressure, temperature, and humidity. Okay, we've been experimenting with those, and we have finally worked our way up to a 76-foot diameter version of this thing that I'm going to show you here in a videotape in just a second. And that large balloon will carry about a 50-pound payload to an altitude of about 35 miles and will float in the atmosphere. I'm sorry, 110,000 feet. Let's keep everything in British units and just make it in hundreds of thousands of feet. Now there are balloons of this type that can go up to 170,000 feet and carry 10,000 pounds of cargo. And I'll show you an example of a big one, not of this material, but of this general type of ballooning in just a couple of minutes. But so you can have your choice. We have flown a little one up to 64,500 feet. It was 26 feet in diameter, and it carried a 30-pound payload to 62,500 feet. And once they're up there, they stay. Now, I need to explain real quickly the difference between 3 different kinds of balloons. One is the extensible rubber balloon. It's like blowing bubble gum. You blow the balloon big enough and big enough and big enough. You load it up with helium here on the ground. As it rises, you give it net free lift. You put in too much helium, so it just doesn't just balance the payload. It takes off and goes up. And it will go up to about 95,000 feet, get to be 30 or 40 feet in diameter at that altitude, and burst. And you have a parachute system on there that releases at that point, and down comes the payload. Okay, and that's what the typical radio sonde flights are over here at the airport that are flown 6 o'clock in the morning and 6 o'clock in the evening every day. Those are flown at the major airports all over the country. Okay, but they just they go up about an hour and take about 30 minutes to come down. Okay, now that's one kind. That's the rubber or neoprene extensible balloon. Then there's the kind called the zero pressure balloon that's made of mylar or polypropylene or polyethylene about this weight. This is a half mil or 12 microns thick. It's a third as thick as a human hair. Okay, and this kind of thing in those materials, not this nylon, are made into a balloon that is kind of pear-shaped. And down here on the ground, when you fill it up, it's a long balloon and you just put a bubble of helium in the very crown of the thing, hang a pre-deployed parachute on the bottom of it, and hang your payload below that, and then release it, and you put in again some net lift. The balloon goes up and expands as it goes, and when it gets to altitude, it burps off the excess helium that you gave it to cause it to rise quickly. It goes up about 1,000 feet a minute, takes a couple hours to get up to, say, 110,000 feet or so, and when it gets to that altitude, it burps off the excess helium, and it stabilizes at float altitude in the daytime. But at night, it cools, and it shrinks, and it displaces less air, and thus it starts to come down. And what you have to do in order to keep it going is drop some ballast, some real fine sugar sand. And when you do that, then it'll come down to, say, 85,000 feet and level out, and you drop about 10% of the gross weight of the system when you do that. Then when you go floating along at that altitude, then in the next morning, the whole system is lighter, so it heats up again and goes back up to float altitude, burps off the excess helium, and floats at that altitude again. And the next night, it comes down lower, and you have to drop more ballast. And about 3 days of that, and you've dropped your whole payload in ballast. So it's all over with, and the balloon comes on down and hits the deck. There's nothing you can do to stop it. So you can get 2- and 3-day flights, and a lot of people do that. The National Scientific Balloon Facility at Palestine, Texas, it's operated by NASA, down east of Dallas, southeast of Dallas, flies balloons on missions like that all over the world. They fly them from Antarctica, they fly them from Canada, they fly them all over the United States. But those missions last a very short time. Then there is the balloon that is called the superpressure balloon, and it's a sealed sphere. It actually looks sort of like a navel orange. It's kind of puckered right at the meridian. But that balloon doesn't vent any gas when it gets up to altitude. And when it gets there, it stretches a little bit. It straightens like crazy. This stuff can handle about 20,000 pounds per inch tensile stress. So it is very, very strong material. It's about as strong as steel for an equivalent thickness. So it just holds the gas in the daytime. It strains like crazy, but it doesn't really change its volume very much. At night it relaxes, but it doesn't lose its shape. It's still a sphere. It's roughly the same diameter. And as a result, it stays at the same altitude at night. And the next day it stays at the same altitude and the same at night. And we expect that we will be able to float balloons that'll stay up for like 3 years. Okay? Ultimately, the UV will degrade it, either the basic material itself or the seams, and down it will come. These seams are just glued. There's a special glue that's better at minus 100 degrees C, and this stuff has better tensile strength at minus 100 than it does at room temperature. So it's great material. And these balloons, using this material, are called superpressure balloons, and they're built by Winson International down in San Antonio, Texas. And they're the kinds that we're experimenting with. We had hoped last Thursday to be able to launch one of these balloons from the new Denver airport, the new airport northeast of Stapleton, and go around the world. But we're still hung up on this kick of, you can't fly over my country because you were bad guys back in 1957. Now, the Russians are not saying that, but the State Department is concerned that they might say that. And we've got friends in Russia who are saying, come on over. We've got ham friends in Russia that are saying, come on over, fly a balloon over here and drop it in our backyard, or just let it go by and we'll track it for you. And the State Department is still concerned about the old issues. They don't want to raise any old specters. So we're one of these days probably going to lose a balloon, and it's just going to go around the world, and there's not a darn thing we can do about it. So as it turns out, there is no law. There is no law that says you can't fly around the world. But it's just a kind of an agreement, an international agreement that people have made. But I haven't found anybody who can come and arrest us if we do this. So one of these days we probably will just let one go. But we haven't worked up the courage to do that just yet, or the frustration level hasn't gotten quite that high yet. But we're going to have a very simple, peaceful balloon that has amateur radio on it and basically nothing else except for one little ozone sensor. And how could that be injurious to anybody's health, or how can that be a warlike act, or how can that be bad? If our hearts are pure, we think that we'll probably get away with this without getting shot. Okay, and that might be the balloon that goes from the Salt Lake fairgrounds over here on the 18th day of September. That might be the first one. Well, that would have to be by a vote of all parties concerned. I don't want anybody participating in something they don't feel good about. Anyway, we do have a balloon already built, a balloon that will take us up to 110,000 feet and carry a 50-pound payload. Now, when you fly these little balloons, these rubber balloons I talked about, if you keep your payload weight below 12 pounds in 2 6-pound packages, you don't need anybody's permission anywhere in the world to fly those burstable rubber balloons. You can just send them up, and you don't even have to tell the FAA. You don't have to ask anybody's permission. And a balloon is like a sailing vessel. It has the right of way. Everybody else has to avoid it. An aircraft, a glider, or anything else, a missile, anything has to avoid that balloon, okay? It has the right of passage. Now, the Russians didn't pay any attention to that when they shot those balloons down back in the late 50s. And they still have shot down French balloons that have wandered over their way in recent years as well. Okay, now, what we've been flying is an ozone sensor this is the scientific part of this thing that we're hoping to be able to cooperate with the amateur radio community on. It's an ozone sensor which looks at the sun. It only works in the daytime. It looks at the sun in 4 different wavelengths, down in the ultraviolet portion of the spectrum and 1 in the visible portion. The visible one, the visible channel, is strictly for in situ reference purposes. It's to give you an on-the-spot calibration, an onboard calibration. The other 3 wavelengths look at different portions of the Hartley and Huggins bands of ozone absorption of ultraviolet light from the sun. And if you look at the comparison of these different wavelengths, you can actually determine how much ozone there is between you and the sun. And if you track the sun across the sky from sunrise to sunset, you're looking through a lot of ozone, a little less, the least, a little more, and out to the horizon again, you're looking at a lot of ozone. And you can actually profile the concentration of ozone above the balloon during that day's passage. Now, so we have an ozone sensor on there that's built by one of our physics graduate students, and we have another batch of these being built that are better. And we also have a GPS receiver on there. It actually was, let's see, which one do we have? Magellan. It's a 5-channel Magellan receiver, and it listens to the stable signals coming from 3 satellites are all you really need. 4's better. 2 gives you position, and it doesn't give you altitude. 3 satellites, if you receive signals from those and compare your position to the known orbits of those spacecraft, they're precisely controlled and precisely known. And it's free. It doesn't cost you anything to listen. And anybody in the world can listen to these satellites. There's no law against listening. If you make a comparison of 3 of those satellites, you can determine your own position to within about 100 meters accuracy. Now, the Air Force or the military they have P-code systems so that they can determine their positional accuracy within a few meters. They don't allow the civilians to do that for fear that somebody will launch missiles at us and be able to pinpoint the White House or something like that. But in any event, you can defeat that by using what's called a come on, somebody, who's a GPS expert here? It's a differential GPS where you compare the signals from a receiver you have on the ground with the one in the balloon, and you can even take out the fuzz, and you can determine within a few meters where you are. Okay, so it's a wonderful system. For about $500, you can fly a receiver that'll do the job, including the antenna. The prices have come down from $10,000 to $5,000 to $2,500. I paid $1,100 for the one that is right now sitting on top of Black Pine Peak up in Idaho in about 30 feet of snow, or 15 feet of snow. I'll tell you that story in just a second. Anyway, we use a GPS receiver. We have been flying an ATV transmitter, and we've been having varying results with this. It's a UHF ATV camera transmitter with a 15-watt amplifier on it because we weren't getting very good results at a watt, and we thought we'd go to 15 watts, and that uses a lot of power. We use lithium batteries that we buy. We buy 15-volt, 15-ampere-hour packs for $10. We buy them $100 at a time, buy 10 packs. They're old, surplus, out-of-date military lithium batteries we buy from somebody. They're made by Saft. We buy them from an outfit in Philadelphia. They're surplus, and they work like a champ. They're really great little power supplies. Although we also are going to solar panels and rechargeable NiCads for these long flights. We have to. We can't just depend upon the lithiums. Okay, and we also then fly a packet downlink that it's a VHF packet downlink. It's a Motorola. I'm stumbling. Somebody tell me a good Motorola transceiver. Let's see. It'll come to me in just a minute. Anyway, we fly a Motorola transceiver, and we use that for our command uplink and for the packet downlink, and we use standard packet code, and we have a whole bunch of... Now, we go into a Campbell Scientific data logger, and we store everything. The data logger does all the sampling, stores the information, and then modulates the packet transmitter. And we have a DTMF decoder in there for receiving commands to terminate the flight. We can cut the package down by burning a hole in the top of the balloon, and at the same time firing guillotine cutters that that cut a 550-pound nylon line that has been suspending our parachute. We have a 12-foot diameter canopy that drops a 50-pound payload to impact at the earth for about 15 feet a second, about like a paratrooper would. Let's see now, what else do we have on board? We did have a system. We were going to fly a digipeater, and we got into some difficulty because too many people got to using the digipeater, so it just stayed on constantly, and it desensed our command receiver, so we were never going to be able to cut the system down. So we didn't fly the digipeater. We got some help from the Jim. He's an FAA controller out here at the airport. What? Rudnicki. Rudnicki put that package together. He put in a TNC and this little guy right here, as a matter of fact, this 2AT. And we'd like to fly a digipeater one of these first days, but we're going to have to get into a UHF command receiver and a VHF digipeater to be able to make that work. And that's another thing that we have yet to do. We really do need to improve things with respect to our ATV. We have not had good results. I'll show you some results that we got in, no, I don't have that video with me, but it's pretty crummy. We've gotten a lot of snow. We're out about 150 miles, and we should have been able to get much better data than we did, or much better imagery than we did from this from this machine. Okay, now let me just show you a quick video of one of our launches from Houston, Texas. We were down in Houston at the Johnson Space Center, or close there too, launching a balloon recently, and it was going to fly to Jacksonville, Florida, and the crew in Jacksonville were going to bring it down. There were a bunch of fox hunters in Jacksonville. They have a very organized club there. My gosh, they've got about 100 people who go out and do the chasing, and they have an aircraft, and they've got all kinds of support gear. We use an aircraft up here in Cache Valley as well. And let me make the point that we have flown 12 balloons altogether now, and we had never lost one until we flew up at Snowville, Utah in late February, and it went up into Idaho, got up to 108,000 feet, and it was sailing along and minding its own business, and we had a balloon failure. And the whole system came down on top of Black Pine Peak, and our 50-pound payload, in which we have invested about 10 grand of our own money, is sitting on top of this peak up there somewhere. And it's the snow. I was up there looking at it with my wife last weekend, and it's still not at all accessible, but we will be going in there on horseback. We were going to go in on skis and snowmobiles and so on until the avalanche season came along and defeated our purposes. So we'll go up there and have a run with on horseback. The Weber County Junior Posse are going to take us up and look for it, but it looks like it might be late June before the snow is down enough to be able to do that. So we really had a cocky record. And by the way, this one that we were sending to Jacksonville, Florida, wound up in the Atchafalaya Swamp near Baton Rouge, Louisiana. And it took us 2 days of fox hunting to go in and get it. We were getting GPS packets on the ground. We knew exactly where it was, but the swamp was so thick and it was so yucky, and we were, in the stuff up to about here, and we didn't have any what are called Louisiana Reeboks or hip boots. We didn't have any Louisiana Reeboks on, and we also, they kept saying, y'all got to realize that around here, we have cottonmouths and water moccasins and alligators and black bears and all that sort of stuff. I guess they do, but we didn't see any anyway. But finally a deer. Oh, and there were guns going off all over the place. This was in January, and it was deer season, and there were guns just bang, bang, bang all around us in the swamp. And so we finally chickened out and pulled out one evening, and that night a deer hunter found our payload for us, and it was sitting there, and we had the gain up on the T50. Okay, P50, Motorola, okay, and we had the gain up on the receiver, and it was sitting there, and somebody thought it was a packet terminal, some guys from the Louisiana Power and Light or something, or Cajun Electric Company, and they were trying to access the node, and it was going pew, pew, like this, and this deer hunter looked at this thing, and he thought, what the heck is that? And we had flashing lights going, and it was around dusk, and he really thought this was something from Mars. So he shot his deer, put it on his little three-wheeler, and got out of the swamp. And he told the farmer there, and the farmer said, oh, that's what those crazies from Utah are looking for. So anyway, he went in and got it and brought it out for us and salvaged it. And it was in great shape. It was sitting there bleeping away. It's still working. And we also have some beacons on board. We have VHF CW ID beacons going all the time for DF purposes. And we were in there with our DFing gear. Like you notice in QST this month, the big article on DFing, and you guys are going to be doing this as an exercise next month anyway. That's the kind of gear that we were using to try to locate it. Okay, well, not to ramble much further, I'll show you a couple of quick videos, and then I'm going to make you a proposition. Okay, and then we'll see if you guys want to get involved in this business. Let me get this video real quick. Oh, I don't think this one doesn't have any rational conversation. Okay, this is the payload. Now, we made this payload by machining aluminum plate in what's called an isogrid pattern. We take a computer-controlled mill, a CNC mill, and we machine plate in a triangular grill pattern, and then we drill and tap holes at each of the nodes in between these triangles, and you can mount. It's great, and we put plates inside that are, again, grill, and you can mount your equipment anywhere in there. It's a really sweet system. This actually is a little satellite that we're planning to fly in a getaway special canister in the space shuttle. We have flown 28 experiments on the space shuttle so far, with student experiments up at Logan, and that's the next one we're going to kick out of the shuttle on an experimental satellite. This is Stan Wellard, N7YTK, and this is Bob Goodsell, W7LTH from the Bridgerland Club. And now the wind was blowing a little bit that morning, and it was drizzling, and it was a very yucky morning, but this is how you fill the thing up. We just had a NASA truck back there full of K bottles of helium, and we pre-inflated this bubble, and you hold the rest of it down here with a special rig that releases whenever you get ready to launch. And this is the thing laid out. It's quite a good-sized balloon, and here's the parachute that's pre-deployed. We had flashing lights on the balloon. We had a locator beacon, a CWID beacon on the balloon, as well as on the payload. But unfortunately, that night, this balloon, we finally had to cut it down at 12:30 a.m., just after midnight, and we've been driving from Utah down there to get ready for 3 days. We got in a big bunch of snowstorms before we left before we left the state and before we left Colorado. And when we got down there, we were a little bit beat, and we flew the balloon one morning at 8 o'clock, and we chased it till midnight, and we were finally shot, and it was going into the Mississippi River. So we cut it down, just missed the Mississippi by 5 miles, and darn near hit the Atchafalaya River, and wound up in this big swamp down there by Baton Rouge and in between. And anyway, we did not have an opportunity to chase the balloon. Normally, the balloon, when you burn the top out of the balloon, we actually use dynamite fuse, and then with little quick matches that start the fuse burning. Dynamite fuse will burn underwater, in a vacuum, hot, cold, whatever you like, 100 below zero, and we just burn a big V out of the top of the balloon to release the gas. And the balloon comes down, usually, we've dropped them over here around Evanston, Wyoming, and over around Cokeville, and the balloon is almost always within a mile of the parachuted payload. The ballistic coefficient, if you will, the drag on that, the drag versus mass of the balloon is about like the parachuted payload. And they almost always come down about the same distance, same location. Okay, I'm getting pretty close now to time to let it go. It's kind of an awkward looking thing. It's sort of a morning glory shape. The top plate of this balloon is down inside itself here. Now here we fly an FAA transponder in a package underneath here just to make the FAA feel comfortable. You don't have to do that. When you get a payload that goes over 12 pounds, you must coordinate with the FAA. You must give them at least 24 hours notice of where you're taking off. You don't have to ask permission. You just have to notify them of where you're going, from where you're going to fly. You have to give them the characteristics of your payload, and you must have a reliable method of telling them where it is as it passes through the controlled airspace at 20,000, 30,000, 40,000 feet. Once you get above 45,000 feet, they don't care. You can turn everything off. They don't give a hoot. They do care when you come back down through controlled airspace again. You must give them 30 minutes notification that you're about to come down, and then you must, in fact, give them a signal. Now, we put a little corner reflector on here in case everything crumps out, so that we could be actively tracked. That's a pretty puny corner reflector, but it meets the rules. And then, anyway, this transponder operates, as I say, through the middle of it. Now this is a static launch, so all we're doing is letting it up into the vertical, and we have some Velcro up here at the top, and when we yank on the Velcro, it releases the whole system and away it goes. And you can launch up to about 100 pounds this way by hand. You can launch a 1,000,000 cubic foot balloon by hand. Okay, there goes the Velcro stuff falling off. Here goes the balloon into the gloomy overcast, and it's slowly starting to fill out. This is as big a balloon as we have flown. That's a 76-footer, and it weighs about 20 pounds, and the payload down here weighed, in this instance, 50 pounds, and with all the gear that I told you about. And it was our beacons go for about 4 or 5 days, so that our beacons have always operated on the ground except for the one up at Snowville. I don't know why it did not operate on that peak. I think it's down deep enough in the snow that there's enough attenuation of the signal that we're just not getting out of the snow. Went down in a deep side canyon, and we think it's probably 10 or 20 feet down. We have no way of knowing because we lost GPS when it went down. Okay, that's the big one. Now, let me show you a different, now this is going to go into the overcast, and we aren't going to see it in just a few minutes' time. And since we're running kind of long, let me skip to the next one, which is a big balloon. This will give you a feel for how big they get. Now, I don't advocate that we get involved in this one, but this is how big they can get. That'll just take a couple of seconds to rewind, so I'll do that. Otherwise, I'll forget. The proposition that I want to make you is if you people would like to work on a payload, I'll furnish the parts. I'll furnish the money for the parts if you will furnish the labor. And you can decide what you want to fly. If you want to fly a digipeater, or for example, we can fly a 10-meter fireball transmitter that only draws 75 nanowatts. There's a guy named Bob Moody who invented the fireball. And you know Bob Moody? He was involved with us in this launch down in Texas. And he was going to be involved in the Denver launch. And he's trying to set distance records. He's, I think, at 100 milliwatts, he has transmitted on a balloon from California to Bill Brown up in Connecticut. And he's established that record. Now he wants to establish worldwide records. So he's providing us with fireball transmitters to fly. And they draw so little. He's down to 75 nanowatts now. And so he powers them with one little tiny solar panel. And with something as simple as a little fireball, we'd probably put 150 milliwatts on it just in case. And if you fly that and you put on and you let your solar panel go off the air when the sun goes down, I don't mean let it, but it will, it happens, you can determine where the sunset line is at that altitude. Okay, suppose we're up at 110 or 20,000 feet. That's a pretty nice place to fly. And when the sun goes down, the fireball goes off the air. Now, it also has been modulated. He's got it chopped, and he chops it at a frequency that corresponds to the temperature. So you know what the temperature is there, and so you'll know your altitude pretty well from atmospheric temperature effects because you know that profile pretty well. And you know then when it chops off where you are, where the meridian is, and then if you use a bunch of directional antennas at 10 meters and DF on it, you can determine where it is in latitude, and that gives you where you are in longitude. And you can tell how far it's traveled that day. So you write up your ship's log and say, well, we traveled 150 miles today or 1,000 miles. You can actually cruise anywhere from 150 knots to darn near zero. In the wintertime, the wind at these altitudes blows from west to east in the stratosphere at velocities up to 150 knots. Then in the spring and the fall, the wind stops. And you can have a balloon stand right straight over your head for 2 or 3 days at a time. And then in the summertime, it reverses and goes the opposite direction. It speeds up to about 100 knots. So we can determine the wind circulation pattern. And by the way, the balloons don't just go straight west to east. As you get up around the poles, they go round and spiral into the pole in the northern and the southern hemispheres both. And so we know that in the southern hemisphere, and we deduce that from satellite measurements in the northern hemisphere. And so you can learn what the circulation patterns are in the atmosphere, and you can measure ozone distribution and temperature and pressure very simply and very cheaply. And if you do this on a volunteer basis all over the world, citizens can actually determine what's happening in the atmosphere on their own. And I think that's neat. And kids get involved, and amateur radio operators get involved, and it means we don't have to just ask the government to do things for us. We can do things on our own. And add archival quality data to the to the fund of knowledge about the atmosphere. And I just think it's an exciting public service project that is befitting the high standards of amateur radio. And now let's see, let me eject. Anybody know where the eject is? Why is it that every one of these things is different? Every one in the world is different. I've never seen two alike. You can't make any money in this business. You can only sell one of anything. I think this has audio. Is it running? Did it do something?
Much of an airport here at all if the Army had not built one here back in the 40s as a training base. The old hangar they left.
This is Fort Sumner, New Mexico. I didn't get it started quite early enough.
Ballooning headquarters. Inside, researchers from the Jet Propulsion Lab and other institutions are preparing a 2-ton package of instruments that will be sent to an altitude of 120,000 feet. Their target of study, the ozone layer that protects us from the harsh rays of the sun. Their instruments will take the best look ever at what may be causing damage to the ozone layer and just how much damage there may be.
Each one of the instruments is extremely sensitive. Short of launching a satellite, there is really no other way to study the stratosphere than to go there.
The process starts at 3 in the morning. The launch crew is from the National Scientific Balloon Facility in Palestine, Texas, which for the past couple of years has been run by New Mexico State University in Las Cruces. They provide all launch services for the scientists, including a meteorologist.
The winds at the surface need to be under 6 knots. Then we have to look at the winds between the surface and 800 feet, and they really cannot be over 10 to 12 knots.
Go ahead and lay the balloon down. To carry the 5,000-pound payload to an altitude of more than 20 miles takes a huge balloon. Laid out, it is 600 feet long. The balloon costs about $80,000 and can only be used once. The decision to fill it is not taken lightly. If the 45-minute filling begins and then the winds get too gusty, the balloon may have to be destroyed on the pad. But this day, the thousands of cubic feet of helium go in smoothly. The weather stays perfect, and the balloon is ready to depart. As the craft climbs, scientists monitor radio signals. 2 hours after they launch the balloon, it reaches float altitude. The gas has now expanded to inflate the balloon to almost 400 feet in diameter. A chase plane is sent up, and 1 day later near Gallup, the crew calculates the wind drift, and explosive releases are fired, lowering the payload by parachute and turning the balloon into a 4,000-pound blob of plastic. This flight is the first of 11 this fall for Fort Sumner, and scientists say their ozone instruments performed well. Near Gallup, Bob Martin, Your News, New Mexico.
Well, that illustrates the other end of the spectrum. Balloons up to 40 million cubic feet have been flown by the people at NSBF, and those balloons are, they're so large that you could put the Houston Astrodome inside them. And you don't know if it's a good balloon until you fly it, because there's not really truly a way to inspect it adequately. Now, the beautiful thing about this stuff is this has lousy tear strength, and when it's manufactured, it is pulled in 2 directions. It's a biaxial nylon film material, and if there's a pinhole, it goes, it just rips. So there's an automatic quality control process here. If it doesn't rip, it doesn't have pinholes. In some of these other balloons that people fly today that are very expensive, they have to layer several layers of material, hoping the pinholes don't line up in the same spot, and they usually don't. And they go off and do inspections on them, and they put little pieces of tape on them. And it costs an awful lot of bucks, $80,000 for one of those bigger ones. Of course, you know, these other balloons would be expensive too in that size. I'm not saying that's not true, but these are a lot simpler to make. They're a single layer. Super pressure balloons that have been flown in the past, they had no adequate way of transferring the load from the spherical shape of the balloon down to the payload. You get a load of infinity right at the vertex of the balloon. So they had to put a big net over the balloon so as to make the load distribution path sort of pear-shaped. And the difficulty with that is that when you try to launch the balloon, the wind's blowing, and the fabric, this material gets blown into the net, and it sort of herniates. Actually, the stuff gets trapped, and it'll herniate and burst, and the balloon comes down. Even a little balloon like we are flying here cost $30,000 in former ballooning. These are about $2,000, and they will come down. These are very experimental. We're flying the first ones ever flown, and they haven't yet gotten to the point of mass production. Therefore, the prices are still high. But anyway, if you people would like to work on a balloon that we're going to fly from the State Fair, we're going to have a big kid day out at the State Fair on the 18th of September. This is something that Bob Bennett and I are working on together. And we're going to fly a balloon from the infield at the fairgrounds. And if you would like to build the payload, I will pay for the material that goes into it if you will put the labor into it. And again, you can decide what you want to fly. We might not have an ozone sensor on this particular one. Oh, and on this particular one, we'll fly it out here somewhere. Let's see, in September? This will be a low velocity time of the year. The winds might be going either direction or no direction at all. And then we'd have to go out and DF on it and bring it back. We'd have to get a ground team together to go racing out there with our fox hunters and get it down. There's a group over at the Edge of Space Sciences in Denver. There are groups all over the country that are flying rubber balloons, all over the place. Cincinnati, Connecticut, down at Houston, and Denver has a really good team. They've got 100 people on their team, all very organized with the grid. Everything is gridded on the map, and everybody knows where to go and where to look for the balloon. And they just DF on a transmitter. They don't have a GPS. We have the advantage of having a GPS receiver, but if you wanted to have fun, we wouldn't tell you where it is. And you just have to go find it and look for it with your fox hunting. And if it gets lost, we'll know where it is from the GPS system once we find this payload and bring it back. And get the GPS transmitter or receiver back again. Well, by then we'll probably be able to buy a new one. So, if you people would like to play, we'd love to play too. So let me know, and through your officers, and we'll get started on it. Okay? Are there any questions about it, or any comments? Yes, sir. Who relayed on 70? I don't know. We were operating on 2 meters. You did? Yeah. Well, that was okay, let me tell you. That was a goof on the part of the balloon manufacturer. It was supposed to be a zero pressure balloon. Okay, it was supposed to vent when it gets to altitude. But in the interest of costs, since I'm paying for this out of my own pocket, I've got a sounding balloon, which is about 126,000 cubic foot balloon that they normally send up ahead of these monsters. And it just to track the winds at the last second so that then they can send up their big balloon and know where it's going to go on the way up, on the ascent phase. Well, those normally just go up to altitude and burst. But the balloon manufacturer was to slit this balloon down near the bottom so that when the helium worked its way down to that level as the balloon inflated, it would vent. And they had a vent that was about 5 inches across, and it should have been about 5 feet across. So with the balloon, instead of slowing down and leveling out at 108,000 feet, was still going like crazy when it got to 110. It was still going 1,000 feet a minute, and pow, it burst. At the time, I said, no, that can't be. We've had an instrumentation failure, and the balloon crew guys looking at the packet were saying, hey, this thing is, all of a sudden we've lost 10,000 feet in the last minute. I said, nah, we've got an instrumentation problem here. Not to worry, guys, it's still up there. And the next minute, well, it was 20,000 feet lower, so then I'm desperately sending the cut down command, forget it. In 2 minutes' time, this thing is getting all wrapped up in polyethylene. That was a polyethylene balloon. And so there was no hope. We lost the FAA transponder at 40,000 feet. So something violent was going on the way down. And we also lost the GPS at 15,000 feet, and we lost packet, we lost the beacon. So I don't know what it was doing, whether it was wrapping its antennas all up in a nice plastic cocoon. Now I hope that's true, because that'll help keep it safe in the snow melt in the spring. But some of our stuff's hermetically sealed and some of it is not. So that was a straight goof. I was trying to drop it on Malta, okay, in Idaho. And the winds, if I had cut it properly, it would have sailed right down and landed near Malta. As it was, it burst early and landed on top of Black Pine, which is 9,200 feet tall, sir. We just use a 20J pole for the packet, okay? We have a wagon wheel, or a little wagon wheel that we get from, I've forgotten what his pre-call is, but he's OAL, the Old Antenna Laboratory. OAL is his last part of his call over in Boulder, Colorado, for the ATV. It's a wagon wheel, horizontally polarized. We use just a whip for the CW transponders, or not transponders, but beacons. I guess that's it. Okay, and the GPS has what looks like a legs pantyhose dome on it. I don't even know what the antenna looks like. It comes all sealed up. I don't even know what it is. To receive the GPS, then it goes on to the Campbell Scientific and then into the P50 transmitter on the way down. Yeah. Yep. I didn't invent that. But on the NewSat, which was the first satellite that we flew out of a gas can on the shuttle, we used just some whips that popped out, and we used fish line to hold them together, and then a piece of we just heated a piece of nichrome wire, and we reasoned that the nylon would ultimately degrade in the atomic oxygen in the upper atmosphere in the event that we were not successful with our nichrome wire deployment. But it worked anyway. Yeah. Okay. Anybody else? Well, I appreciate your attention, and I'm sorry it went this long, and thanks very much. Be talking to you later.
Well, I guess we got to go figure out a way to ask our spouses. Well, I'd like to just get a 1,000,000 cubic foot balloon, dear. Any further business? I'd like you to take your chair and stick it back on that rack, and we'll see you next month for DFing.